Good morning, students. We're going to start the class. So, number system, so far we have discussed Indian international system and the basics, place value, face value, and we discussed yesterday divisibility rules. So, some more questions for you to try from previous year Sainik school exam. All of you try this question. This question came in 2020. Write Roman numeral CD XXX IX in the Hindu Arabic numeral. Arush, can you give me the answer?
Sir, may I tell the answer?
Yes, yes. Go ahead.
Sir, option A is the answer.
Can you explain how you got the answer?
Sir, because
Yes,
before D, C is there, so we
yes.
have to subtract.
So first let me write the Roman numeral CD XXX IX. So where you want to divide this? Can I divide like CD XXX and IX? So three separate groups I can check like this.
Yes, sir.
CD, what is the value?
400.
400. And what is XXX?
XXX 30.
30. IX.
9.
So if you add them, so you'll be getting the answer 439, isn't it?
Yes, sir.
So good answer is A. Correct answer. Next question, all of you try. Arush, you can mute yourself.
Okay, sir.
Find the difference between the greatest and the least number that can be written using the digits 6, 2, 7, 4, 3, each only once. Harshvardhan, can you give me the answer?
Okay, sir.
Yes. First read the question.
Sir, find the difference between the greatest and the least number that can be written using the digits 6, 2, 7, 4, 3, each only once.
Okay. Using these digits, what is the greatest number that you can write?
72,432.
Come again?
76,432.
Yes, the greatest number we can write 76,432. So to get the greatest number, we will arrange the digits in ascending order or the descending order.
Descending order.
Okay. What is the smallest number created out of them?
223,467.
Yes. Yes. Between these two numbers, they're asking which result?
Difference, subtraction.
Yes. Now after subtraction, what is the answer you got?
Sir, wait.
What is the answer you got after subtraction?
Sir, 1 minute. Sir, 52,965.
52,965. Which option is correct, Harshvardhan?
A.
Option A. Okay, very good. You can mute yourself.
Sir, today I joined correct day.
Yes.
Okay.
So we discussed rounding off to nearest tens, hundreds, etc. So all of you try this question now. Estimate the product by rounding off each number to the nearest hundred. Estimate the product 5,980 into 428 by rounding off each number to the nearest hundred. Pranay, can you answer this question?
Sir,
Yes, Pranay.
sir, you said this question we have to write the question.
Yes, you have to write and solution also.
Okay, sir.
So Pranay, can you explain this question?
Sir,
Okay. Shall I write those numbers?
yes.
5,980 multiplied by 428. So first we have to round off or multiply.
Sir, multiply.
First we have to round off and the answer we have to first we have to multiply and we have to round off.
Yes, sir.
No, look at the question properly. Estimate the product by rounding off each number to the nearest hundred. That means first each number you have to round off to the nearest hundred, then multiply. Okay?
Sir, the question I don't hear.
So you have to estimate, they said clearly, by rounding off each number to the nearest hundred. So each number we have to round off to the nearest hundred first, then multiply.
Okay, sir.
So how can you find the nearest hundred of this 5,980?
Sir, sir, 900 round of
So the hundreds place we have to round up, that is rounded up 9. What is the next digit after that?
8,
8. So 8 is there in which groups? 0, 1, 2, 3, 4 or 5, 6, 7, 8, 9?
5, 6, 7, 8, 9.
So 59, which change is required?
Plus 1,
Yes, we have to add 1. So it's going to be 60. And outside the box, what will happen?
0.
So this is 6,000. So what is the nearest hundred of this number? 5,980. It is 6,000. Very good. And next number, how can you round off to the nearest hundred?
Sir, rounded of 400.
Yes, round up 4 and check the next digit. So the next digit is 2. So 2 is there in which group?
1, 2, 3, 4.
0, 1, 2, 3, 4. So what is the change required?
No change.
No change, as it is we have to write 4 and these two digits are going to become zeros. Now is it easy to multiply these two numbers?
8.
So 6 fours are how much?
Sir, 24. 5
Followed,
zeros.
followed by 5 zeros. 1, 2, 3, 4, 5. So which option is that?
So option C.
Yes, we got the answer C. Very good, Pranay. You can mute yourself. All of you try this question. The product of a non-zero whole number and its successor is always divisible by 3, an odd number, a prime number, an even number. All of you try this question. All the students involved in the class actively raise hand, ask doubts, explain the questions. Even if you give wrong answer, no problem. I am here to correct you. Yes, Manaswini. Yes, Manaswini, you can give the answer. Is it Manaswini or Jashvi? I think is it Jashvi? Yes, Jashvi. Can you read the question? Jashvi, you are not audible to me. Speak loudly.
Sir, we have to give in poll or chart.
No, no, here only you can give the answer. I'm not creating the poll now. Just you have to explain this question. So you know how to solve this problem?
No, sir, I will try now.
Okay, you can try now. So who want to explain this question can raise your hand. Surya, can you explain this question? The product of a non-zero whole number and its successor. Surya?
Sir,
Yes, Surya, can you answer this question?
sir, is it option D?
You said even number.
Okay. See, no, sir, odd number.
Odd number you're saying.
Okay.
For example, you can take any whole non-zero whole number first. Take any non-zero whole number.
Sir,
Any whole
7,
number. Okay, 4. What is its successor?
sir, 5,
What is the product of 4 and 5?
20.
20 is even or odd?
Sir, even.
You said odd, right?
Okay.
So any example of whole number you take and multiply with its successor, it's always an even number. We can prove it like this here. So the number first one we are selecting. So case 1 I am writing here. We may select an even number, or case 2 we may select any odd number. If you select any even number, what is its successor going to be?
Sir, odd number.
For any even number, the successor is odd number. Okay. And if you select odd number, what is its successor?
Sir, even number.
Even number. So now you can get the answer. Even into odd, always going to be
Even.
even. And odd into even is always going to be
Even.
even. So any case, either you select the first number even or odd. If you multiply with successor, final answer will be always even, right? So which option we are going to mark here?
Option D.
Yes, answer D is correct. This even number. Okay.
Thank you, sir. Can I mute myself?
Yeah, you can mute yourself. So yesterday we have completed the divisibility rules, and using co-prime method also we have discussed. So all of you try this question once. All of you try this question. Which of the following 4 consecutive composite numbers? Which of the following are 4 consecutive composite numbers? Who will give me the answer? We know prime number and composite number. What is prime number? A number which is divisible by only exactly 2 numbers, 1 and itself. And if it is divisible by more than 2 numbers, it is a composite number. Sanvi, can you give me the answer now? Sanvi?
Sir?
Yes, Sanvi, can you give the answer?
Sir, option D, sir.
Option D. First, you look at option A and tell me why they are not 4 consecutive composite numbers. In
The
option,
23 is the prime number.
Yes, 23 is a prime number. So that's why option A is wrong. So why option B is wrong?
Sir, 61 is a prime number.
61 is a prime number. We want only composite numbers. And why option C is wrong?
So 57 is a prime number.
57 is not prime number. You check the divisibility rule by 3, Sanvi.
Okay, sir.
What is the divisibility rule by 3, Sanvi?
So sum of all digits.
Yeah, 57 you check by the divisibility rule by 3. What is 5 plus 7?
So 12.
5 plus 7 is 12, which is divisible by 3, right?
Yes, sir.
So 57 is not a prime number, it is composite.
Okay, sir.
So which is prime in option C?
So 59.
Yes, 59. That's why this is wrong. So in option D, are there all consecutive composite numbers?
Yes, sir.
What do you mean by consecutive?
So continue.
Yeah, that means there is no composite numbers left between them. So everything is after 90 we have 91, and after 91 we have 92, after 92 we have 93. So nothing is left between them. So your answer is correct, Sanvi. Answer D. Okay, Stanley, you can mute yourself. And today I'm going to tell you, you must remember all the prime numbers from 1 to 100 at least. Okay? Because every time we don't want to waste time like this, checking a number divisible by this number or not, that number or not. But you must remember prime numbers up to 100. So let us check prime numbers up to 100. So 1 to 10, what are the prime numbers we have? 2, 3, 5, 7. 11 to 20. What are the prime numbers we have? 11, 13, 17, and 19. In 30s, how many prime numbers are there? We have 2. 31 is a prime number. 37 is a prime number. First, we'll write 20s here. In 20s, what are the prime numbers we have? So we have 23 is a prime number, and we have 29 is a prime number. And in 40s, we have three prime numbers. What are they? 41, 43, and 47. In 50s, we have two prime numbers. What are they? 53 and 59. And in 60s, we have two prime numbers, 61 and 67. 70s, there are three prime numbers, 71, 73, and 79. 80s, we have two prime numbers, 83 and 89. And in 90s, there is only one prime number, that is 97. So in all the 90s, we have exactly one prime number, 97. So together, if you count, there will be 25 prime numbers. 25 prime numbers. You must remember. So together, how many prime numbers we have? 1 to 100. 25 prime numbers will be there. So Sanvi gave correct answer for this. The four consecutive composite numbers are seen in option D. Next question. I am a prime number. If you subtract 2 from me, I become divisible by 7. Yes, Sahana.
Sir,
Sahana, why did you raise hand?
sir, can you show prime numbers from 20s?
Okay, you want to copy?
Yes, sir.
Yeah, copy quickly. Manaswini, why did you raise your hand?
Sir, can you please move forward?
I'm on the same screen, no? Prime numbers.
Sir, please go forward, sir.
You cannot see the entire screen.
Yes, sir.
Okay, let me. You are able to see now, Jashvi?
Sir, I'm Manaswini, sir.
Manaswini, are you able to see the screen now?
Yes, sir.
Okay, you can copy. Ritvik, why did you raise the hand? Ritvik? Vaishnavi, why are you raising hand? Ritvik, why did you raise the hand? Vaishnavi?
Sir,
Vaishnavi, why are you raising hand, ma? Vaishnavi, raising hand. Ritvik, why did you raise the hand? You want to give the answer to the previous question? Arush?
Sir,
Yes, Arush, why are you raising hand?
sir, may you show the next question once?
Yeah, I'll show. The people are copying this list now. Let them copy, then I'll show the next question.
Okay.
Abhiday, why are you raising hand? Abhiday?
Sir, can I tell the answer of the question?
Which one? Previous one or next question?
The next question.
Oh, okay. So when you go to the next question, you raise your hand. Harshvardhan, you have any doubt?
sir, no. The
Okay, I hope everybody copied this list and we are going to the next question. So next question, all of you try to solve this. I am a prime number. If you subtract 2 from me, I become divisible by 7. So which option is correct? 29, 19, 31, or 23? I am a prime number. If you subtract 2 from me, I become divisible by 7. Vaishnavi, can you explain this question? I become divisible by 7. Vaishnavi?
sir,
Vaishnavi,
sir,
are you sitting nearby any speaker, TV, etc.?
no, sir.
You can listen to my voice only again.
Sir, but your voice is not clearly audible.
Are you sitting nearby any speaker? Vaishnavi, you try to do one thing. Try to leave the class and join again.
Okay, sir.
My voice only again. Ritvik, can you give the answer for this question? Ritvik, am I audible to you? Shanai, can you give me the answer? Shanai,
Sir, can you tell answer?
I'm asking you, can you solve this?
Sir, 23 is the answer.
Why 23?
Sir, 23 minus 2 is 21.
Okay,
7 will divide 7.
very good. And first of all, they said I am a prime number. First of all, is 23 a prime number?
Sir, 23?
Yes,
Yes, sir.
23 is a prime number. And if you subtract 2, you're getting 21, which is divisible by 7. So this kind of questions you have to depend on options only. Shanai, shall we check one by one from first option?
Sir?
First option 29. Let us check. First of all, is 29 a prime number?
Sir, no, sir. Sir, yes, sir.
29 is a prime number. If you subtract 2, what is the answer you're getting?
27.
Is this divisible by 7?
No, sir.
That's why option A is wrong. And option B. Let's take 19. Is 19 a prime number?
Yes, sir.
If you subtract 2, is it divisible by 7?
17.
Is it divisible by 7?
No, sir.
Next number is 31. Is 31 a prime number?
Sir, yes.
31 minus 2?
Sir, 29.
29. Is this a prime number?
Sir, no, sir.
Or is this divisible by 7?
Sir, no.
Okay. Next 23. If you subtract 2, you're getting 21. First of all, is 23 a prime number?
Yes, sir.
Yes. And 21 is divisible by 7?
Yes, sir.
Yes. That's why both conditions are matching for option D. Very good, Shana. You can mute yourself. We had a discussion of twin primes. I'm going to repeat the question. I'm going to repeat that once again. What are twin primes? Twin prime means two primes. The two numbers should be prime numbers with a difference of 2. With a difference of 2. They are called twin primes. So for example, you take 2, 3. Are they twin primes? Yes, both of them are primes, but the difference is only 1. The condition is difference is 2. So this is not a pair of twin primes. Let's take 3, 5. Yes, 3, 5 is a pair of twin primes. Why? Because 3 and 5 are prime numbers and the difference is 2. 5 and 7 are the pair of twin primes? Yes. Both of them are prime numbers and the difference is 2. 7, 9. Is this a pair of twin primes? No. Though the difference is 2, but both of them are not primes. 7 is only prime, but 9 is a composite number. So first of all, both of them should be primes. Then we have to check the difference. So 7, 9 is not a set of twin primes. So next we can check 11 and 13 twin primes. 17 and 19 twin primes. So like this we have many. So this is the concept of twin primes. So all of you try to solve the next question. A pair of twin prime numbers between 70 and 100 is. So between 70 and 100, which option is giving a pair of twin primes? Anybody interested in answering this question can raise a hand. Both of them should be prime numbers and the difference should be 2. Lakshita, can you answer this question? Lakshita? Lakshita,
Sir?
can you answer this question?
Yes, sir.
Yes, tell me which option is correct.
Sir, can you show option A? I cannot see.
Option A is 71, 73.
Sir, it is the correct answer.
71, 73 is the correct answer. Can you explain why?
Sir, 71 and 73 are twin primes, sir.
Why twin primes?
Sir, sir, I didn't understand upside, sir.
No, if you
No, what is a twin prime?
if you want to call two numbers as twin primes, what are the conditions you are going to check? See, first of all, they are going to be prime numbers and then their difference should be 2. So 71, 73, both of them are prime numbers.
Yes, sir.
And what is their difference?
Sir, sir, one is different.
71, 73, what is their difference?
Sir, 2.
2. That means both of them are prime numbers and the difference is 2. So that's why we can say 71 and 73 are twin primes. Okay?
Okay, sir.
But I will ask you, why option B is wrong?
Sir, 79 and 83 are wrong, sir, because of sir, 79 and 83 had so much difference, sir.
How much difference? What is the
Sir,
difference between 79 and 80? Come again?
sir, 4 difference.
How much difference?
Sir, 4.
Yes, 4. That's why it is not a pair of twin primes. And why 97, 99 is not the correct answer? Option C.
Sir, same like B, sir. That is also had so much gap.
What is the difference between 97, 99?
Sir, 72.
2 only, no, but you said so much difference. But why it is not the correct answer, 97, 99?
Sir, 97 and 99 are not twin primes.
Why they
Sir,
are not twin primes?
Sir, 70 and 100. No, sir, wait.
First of all, you tell me, is 97 a prime number?
Sir,
Is
sir,
97 a prime number?
sir, no, sir.
I told you just now, 1 to 100 prime numbers, how many are there? 25. In 90s, there is only one prime number, that is 97. 97 is prime number only. But what about 99?
Sir, 99 is not prime number.
Why it is not prime number? It is divisible by which number?
Sir,
It is divisible by which number? You learned all the divisibility rules. 99 is divisible by which number?
sir,
Is it divisible by 3?
sir, yes, sir.
Lakshita, you know the divisibility rule of 3?
Yes, sir.
Tell me.
Sir, sum of all the digits.
Okay, 9 plus 9, what is the answer?
Sir, 18.
So 18 is divisible by 3?
Sir.
Yes,
Yes, sir.
18 by 3?
Yes, yes, sir.
Okay, that's why it is not a prime number, it is a composite number. Okay.
Okay, sir.
Why option D is wrong?
Sir, 87 and 89.
First of all, both of them are prime numbers.
Sir, no.
Which one is not a prime number?
Sir,
87, is this divisible by 3?
sir,
87, is this divisible by 3?
sir, no.
What is the divisibility rule by 3?
Sir, sum of all the digits.
Yeah, 8 plus 7.
For 15.
15 divisible by 3.
Sir, no.
15
Sir,
is not
sir,
divisible by 3.
yes, yes.
That
Sir,
means
yes,
15 is divisible by 3, right?
yes, yes.
That's why it's not a prime number.
Yes, sir.
Okay, Lakshita, you can mute yourself. Next one important concept we are going to discuss, that is prime factorization, which is going to be very helpful for us while finding HCF LCM also. So prime factorization. So what is prime factorization? Expressing a composite number, as a product of prime numbers only. That is called prime factorization. For example, we take something like 240. So I want to check the prime factorization of 240. So there are two methods. The first method is called continued division method. And the second method is called factor tree method. So any method you can do it. So 240. So in this continued division method, you are allowed to divide only by the prime numbers. First check by the first prime number. We know the first prime number is 2. So with 2 we can divide. 2 ones are 2, 2 twos are 4 and 0. So again you check by 2. Is it divisible by 2? Yes, we know the divisibility rule of 2. Last digit is 0, it's divisible. 2 6 are 12 and 0. Again it's divisible by 2. 2 into 3 6 and 0. Again divisible by 2. 2 into 15 is 30. Now it is not divisible by 2. So check the next prime number, that is 3. With 3 it is divisible. 3 5s are 15. So when you get a prime number here at the end, you can stop doing the process and you can write the prime factorization. That is 240 is equal to 2 into 2 into 2 into 2 and 3 into 5. So this is without using exponents. Without using exponents. But if you want to use exponents and write, you can write like this. 2 repeated how many times? 2 repeated 4 times. So that we can write as 2 to the power 4 multiplied by 3 repeated only one time. So I can write 3 to the power 1. And then 5 repeated only one time. That we can write 5 to the power 1. So next, factor tree method. So in factor tree method, how can we solve this question? So you take 240. So for continued division method, we took only prime numbers to divide. But in factor tree method, you can take even composite numbers also. So for example, 240, I can write 10 into 24. Both 10 is composite, 24 also composite. This is like a tree and which is going to increase its branches until all the prime numbers are there. So when you reach a prime number, the branch will stop there. When it is a composite number, it will continue making the new branches. So first of all, you check 10 is a composite number or prime number. It is a composite number. So it's going to continue its branch. So you can write something like 2, 5. 2 5s are 10. So 2 is a prime number. This will not continue the branch. 5 is a prime number, which will not continue the branch. So the branch is stopped here. But what about 24? 24 is a composite number, so it is going to continue the branch. So that is, we can write 3 8s are 24. 3 is a prime number, the branch stopped here, but 8 is a composite number, we have to continue. That is, I can write 2 into 4. 2 is a prime number, it stopped here, but 4 is a composite number, we can continue. That we can write 2 into 2. So the final ends of the branches, not the intermediate numbers, you have to take only the final numbers, that is 2, 5, 3. At the end, they should be there 3, 2, 2, 2. So these are going to be the prime factors of the given number. So again, it's going to give the same answer, 240. If I write in the ascending order, 2 I write here, 2 I write here, 2 I write here, 2 I write here, and then 3 I'm writing, and then I'm writing 5. So we got the same answer. Even if you can write in exponents also, 2 power 4 into 3 power 1 into 5 power 1. So if you want, you can copy this concept, and based on this, you're going to get questions. So what is prime factorization? Expressing a composite number as a product of prime numbers only. Should not involve again composite numbers here. Any doubts in this concept, you can ask me. Lakshita, you have any doubt in this?
Sir, continued division method I have not understood.
See, you have to divide only by the prime numbers. Okay,
Okay,
Lakshita.
sir. Okay, sir.
2. With 2 I divided 240. 2 into 120 is 240, right?
Sir, you are not audible to me.
Lakshita, I'm audible now.
Yes, sir.
2, if I divide 240 by 2, I get 120, right?
Yes, sir.
Then 2 into 60 will be 120 again, right?
Yes, sir.
2 into 30. Like that, I'm going on dividing all with all the prime numbers until I reach the prime number finally 5. Okay?
Oh, yes, sir.
Any other students have doubts? You can raise a hand. Nitiksha, you have any doubt?
Sir,
Yes, Nitiksha.
sir, I don't understand factorized tree method.
Factor tree method, what you need to do is you take the given question 240. So not only prime numbers, any factorization possible you can continue. Okay. So I'll explain prime factorization method in another way. Even if you do in another way, you'll be getting the same answer. Okay.
Okay, sir.
So Nitiksha, don't mute yourself. You be there live. Let's see. Litiksha, we take 240. Now don't write 10 into 4. Can you say any other factorization form of 240? Litiksha, it's divisible by 12 also. You divide 240 by 12. What is the answer you are getting? Litiksha, I think Litiksha, you muted yourself. I asked you to stay. Litiksha, is it divisible by 12?
Okay, sir.
With 12, if you divide, what is the answer you are getting?
We will divide.
240. If you divide by 12, what is the answer you are getting?
Right, sir.
12 twos are 24 and 0, right? Yes, Ritisha?
Sir,
Is it correct or not? 12 into 20, 240.
sir,
Is this correct or not? 12 into 20.
sir, 12 into 20.
12 into 20, 240 only, no?
Yes, sir.
Now, the branch at 12 is going to continue or it's going to stop here.
Sir, continue.
Why? Is it a prime number or composite number?
Sir, composite number.
Yes, composite number. How can you factorize 12?
12, 3 fours are.
Very good. 3 fours are 12. Now, the branch at 3 is going to continue or stop.
Stop.
Why? Because 3 is a prime number. But 4 is a prime number or composite number.
Composite number.
So again we can find the new factors. 2 into 2. Now this 20 is a prime number or composite number.
Composite number.
How can we factorize it? Any method you can do.
Sir, 10.
Okay, 10 and 2 you can write.
Yes,
Yes,
sir.
this 10 is a prime
Yes.
number, composite number.
Composite number.
So it can be further factorized. That is 2 and 5. Now every number at the end is a prime number, right?
Yes.
So round up the prime numbers at the end. 3, 2, 2, 2, 5, 2. You got the same answer or not, Litiksha?
Yes, sir.
Order may be different, but you got the same answer, right?
Yes.
I hope you understood now.
Yes.
Okay. Harshvardhan, you have any doubt in this question? Harshvardhan? You're not audible to me. Nishil, you have any doubt? Nishil?
Sir,
Yes, you have any doubt in this question? In this
sir,
concept? Yes.
sir, why you are taking exponents?
Exponents are useful in finding LCM and HCF. So after this factorization, no, we are going to discuss HCF, LCM. They are useful there. That's why.
Okay, sure.
Okay. Jayant, any doubts? Jayant, you have any doubts?
Yes, sir.
Yes, tell me.
Sir, in factor tree method, we have to take only prime numbers.
Yeah, at the end, prime numbers we have to stop. In between, you can take composite numbers, no problem. But when prime numbers are there, you have to stop branching. Okay?
Okay, sir.
Okay. Now, let's solve some questions based on prime factorization. So all of you solve this question which came in 2020 Sainik school exam. What are the prime factors of 37,800? So prime factorize this number and be ready with your answer. What are the prime factors of this number 37,800? If you want to give answer, you can raise a hand. Mayuk, you want to give answer? Mayuk?
Sir,
Mayuk, you want to give answer?
sir.
Yes. Shall I write the number 37,800?
Yes, sir.
Okay, which method are you going to use? You are going to use continued division method or the factor tree method?
The continued method.
You want to use factor tree method?
The continuous division method.
Continued division. Which number you want to divide?
2.
2. Okay. If you divide with 2, which is quotient you are getting? Mayuk, what is the quotient?
So 8,900.
Come again?
8,900. 18,900.
18,900. Okay. Again, it's divisible by 2 next.
Yes, sir.
Okay. What is the quotient?
So 9,450.
9,450. Very good. Again, it's divisible by 2.
Yes, sir.
Okay. What is the quotient?
4,725.
Come again?
4,725.
Okay. Next, is it divisible by 2?
No.
So check the next prime number. How to check whether it is divisible by 3 or not?
So yes.
How can you check?
So 7 plus 2 is 9. 5 plus 4 is 9. 9 plus 10 equal to 18.
Very good. So we can it is divisible by 3. If you divide by 3, what is the quotient?
So 1,700. 1,575.
Is it again divisible by 3?
Yes, sir.
Okay, what is the new quotient now?
So 525.
3 5s are 15 and it is 25, right? Now, is it divisible
Yes,
by 3?
Yes, sir.
Is it divisible by 3? Yes. So, what is the new quotient? Mayuk, what is the quotient?
So 175.
Okay, is it divisible by 3 now?
No, sir.
So, we have to check the next prime number. What is the next prime number?
So 5.
So, is it divisible by 5?
Yes, sir.
How can you check is it divisible by 5 or not?
The last digit is 5.
So 5 3s are 15 and 5 5s are 25, right?
Yes, sir.
Okay, is it divisible by 5 again?
Yes, sir.
Okay, what is the quotient?
So 7.
So 7 is a prime number. Shall we stop doing the division or continue?
Sir, stop.
So which option is correct?
So option B.
Option B. Yes. 3 2s, 3 3s, 2 5s and 1 7. Very good, Mayuk, you got the answer. So if you want to copy, you can. So I'll be waiting on the screen. So you can also use factor tree method. Mayuk, you can mute yourself. You can also use factor tree method, you'll get the same answer. But I suggest practice common continued division method only.
So which like we have to use?
Factor tree method also you can use. I explained now. You can use any composite number, and once it reaches prime number, you have to stop branching. And final numbers we have to copy again.
Okay.
Mayuk, you can mute yourself.
Let me.
Next concept we are going to discuss HCF and LCM. So today we are going to discuss how to find HCF. To find HCF, we have some methods. So method number one, we call it definition method. So according to the definition, What is HCF? HCF means highest common factor. For any two or more numbers are given, we can find highest common factor by listing out the factors. First, you have to write factors. Then you have to identify common factors. And in the common factors, you have to select the highest one. And that will be highest common factor. Let's take a simple example first. So, example, we have to find the HCF of 4 and 6. So for 4, let us list out the factors. 1, 2, 4. For 6, let us list out the factors. 1, 2, 3, 6. Now we want common factors. So what are the common factors? 1 is common, 2 is common. That's it. So let common factors 1 and 2. So in these common factors, which is the highest common factor is 2. So that's why it is 2. So this is called the definition method. So let's take another example for this. Find the HCF of 20 and let's take 48. So we want to find the HCF of 20 and 48. 20, let's write all the factors. 1, 2, 4, 5, 10, 20. 48, let's write all the factors. 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. And we want to write the common factors. So the common factors are 1 is common, 2 is common, 4 is common, and that's it. So let's write the common factors 1, 2, 4. In common factors, the highest one is 4. So that's why we can write the HCF of these numbers is going to be 4. So this method of finding HCF is called definition method. We are using definition to find the highest common factor. And the second method. The second method is method number 2. The second method is common division method. What is common division method? We are going to divide all the given numbers with the same number. But the condition in HCF is if every number is divisible, then only we will take. That is, for example, we are finding the HCF of 60, 48, and let's say 72. So we want to find the HCF of these three numbers. Then, if all are divisible, then only we have to consider. All the numbers are divisible by 2. Let's take 2. 2 into 30, 60. 2 into 24, 48. 2 into 36, 72. Next, again all the numbers are divisible by 2. So 2 into 15, 30. 2 into 12, 24. 2 into 18, 36. Now they are not divisible by 2, all the numbers. Even though 12 and 18 are divisible by 2, but 15 is not divisible. So you should not take. You should take only the number which divides all of them. So 3 works here. 3 5s are 15, 3 4s are 12, and 3 6 are 18. Now there is no number which is dividing all of them except 1. So we can stop doing this process. Only multiply the left side factors. So HCF is going to be 2 into 2 into 3. So you're going to get 2 2s are 4 and 4 3s are 12. So the HCF of the given numbers is 12, and this method of finding HCF is called common division method. In this, what is the rule? The rule is if all are divisible, if all are divisible, then only we have to divide. If at least one also not divisible, we don't take that factor. If all are divisible, then only we have to take. And don't multiply all the numbers. Multiply only the left side numbers. That will be common division method. And next we are going to discuss one important method of finding HCF, that is continued division method. It will be best suitable for very big numbers. Even if you have very big numbers, then this method will give you solution easily. So that is method number 3. That is continued division method. Continued division method. So if you want to copy, I'll be waiting So first copy the first two methods. I'm waiting on the screen. I hope everybody copied. So continued division method, let's take one example, that is find the HCF of 450 and 990. This is the question. So in continued division method, what we do is with 450, you divide 990. With smaller number, you divide the bigger number. 450 into 2, you're going to get 900 and we're going to get 90. With this reminder, you divide the previous divisor. The previous divisor is 45. It will become the new dividend. So 95s are 450 and the answer we got 0. So the divisor which gave you 0 as reminder, that will become the HCF. So the answer for this question is 90. So I'll take one more question. For example, HCF of 28 and 12, we want to find the HCF. So with the smaller number, you divide the bigger number. 12 twos are 24 and the remainder is 4. With 4, you divide 12. So it's going to be 4 threes are 12 and the remainder is 0. So which divisor gave you remainder 0? That is 4. So HCF is 4. So like this, you can find the HCF in this method, continued division method. Until we get 0 remainder, we have to continue. So any doubts till method number 3? You can raise your hand. I'll clarify because there are 2 more methods we are going to discuss. Vaishnavi, had any doubts? Vaishnavi?
Sir, if there are more than two numbers,
More than 2 numbers, what we need to do, I'll explain by taking one example. I will explain by taking an example after this. First, up
okay, sir.
here you have any doubts, you can ask me.
No, sir.
Okay. So, Jayant, do you have any doubt in the first 3 methods?
Sir,
Yes, Jayant.
sir, after the mathematics, which subject will you start?
Today, let's try intelligence because in this week we have taken English and English and GK, but not intelligence. So let's take intelligence topic.
Okay, sir.
Nishika, you have any doubt in the first 3 methods? Nishika?
Yes, sir.
Nishika, you have any doubt in the first 3 methods? No? Samatvika, any doubts in the first 3 methods? Samatvika,
Sir?
you have any doubts in the first 3 methods?
Yes, sir. I didn't understand third method.
Continued division method, what we should do is with smaller number, you divide the bigger number. For example, we are finding the HCF of 450, 900. Which is smaller? 450 is smaller. With 450, you divide 990. 450 into 2 is 900 and the remainder is 90. So with this remainder, you divide the previous divisor, that is 450. So 90 into 5 will be 450. Answer is 0. Therefore, the divisor which gave you 0, 90 will be the HCF. Okay.
Okay.
Lakshita, any doubts? Lakshita, any doubts?
Sir,
Yes.
sir, can you explain? Sir, can you explain common division method?
See, common division method is simple. The rule is if all the numbers are divisible, then only we have to take. Is 60 divisible by 2?
Sir,
Is 60 divisible by 2?
yes, sir.
Is 48 divisible by 2?
Sir,
Is 72 divisible by 2?
yes, sir.
If all are divisible, then only we have to divide by 2. So that's why divided by 2. 2 into 30, 2 into 24, 2 into 36.
Uh,
Next we have 30, 24, 36. They are also all divisible by 2.
yes, sir.
Then I divided by 2. And finally we got 15, 12, 18. Now all are divisible by 2?
Sir, no.
No. But all are divisible by any other number 3?
Yes, sir. Divisible by 3.
That's why I divided. Finally I got 5, 4, 6. Any number other than 1 is dividing all the numbers 5, 4, 6?
Sir?
Any number is there which is dividing all the numbers 5, 4, 6?
Sir, yes, sir.
Other than 1.
Sir?
Other than 1.
Sir,
I said all the numbers, not only few of them, all the numbers.
okay, sir. Sir, 5.
5 is dividing 5, but it is not dividing 4 and 6, no?
Uh,
That's why there is no common factor for all of them. We have to stop doing the process and multiply only the left side numbers 2, 2, 3. Okay?
okay, sir.
So next we are going to discuss method number 4. Before going into method number 4, Vaishnavi asked one question. How can we find how?
Sir, mute.
Yeah, you can mute yourself. How can we find HCF of more than two numbers? More than two numbers. So let's say 1, 2, 3. We have three numbers and we want to find HCF. What you do is first you find the HCF of these two. You'll be getting one answer. With this answer and the third number, you again find HCF. And the final answer will be the HCF of all the three. Not only first two, you can take last two also, no problem. 1, 2, 3 numbers are there. First you find the HCF of these two. For this answer and the first number, you again find the HCF that will give the final answer. Even you can take first and last also. So there are three numbers. First and last, you found HCF. With this HCF and the second number, you again find HCF that will give the final answer. I hope Vaishnavi, your answer is clear. Even if you take more than three numbers also, it will work. 1, 2, 3, 4. Four numbers are there. First, these two you find HCF. These two you find HCF. For these two, you again find HCF. That will give the final answer. So like this, at a time you can take two and carry that HCF forward until you complete all the numbers, and that will give the correct answer. Okay, next we are going to discuss method number 4. Method number 4 is prime factorization. Prime factorization method, but here not using exponents, without exponents. Without exponents. Let's take the same example as we took for the last question. That is, wait a second, I'll reshare. Okay, prime factorization without exponents. I'm taking the same example that we took for the last question, that is last method. Find the HCF of 28 and 12. So we have to prime factorize both the numbers first, then we will get the answer. So 28, we already discussed in today's class how to prime factorize. Divide only by the prime numbers and move forward. 2 into 14 is 18, 2 into 7 is 14, and we get a prime number, we have to stop. And 12, 2 into 6 is 12, 2 into 3 is 6. So write 28 as 2 into 7, and 812 as 2 into 2 into 3, and round up the common factors, that is 2 is common, 2 is common, so the HCF is going to be multiply 2 and 2, you'll be getting 4. So the answer for this is 4. Which method we used? That is prime factorization method. You look at the previous method. Here also for the same question we got same answer 4, and here also we got 4. Next we are going to check method number 5. Method number 5 says use exponents. Method number 5. This is also prime factorization method only. Prime factorization method, but we are going to use exponents with exponents. So if you want to copy, you can copy the previous example. We're going to start the new one. Suppose you get the question, that is find the HCF of, let's take 3 numbers now, 450, 990 and 1620. Okay, this answer we want. So all of you have to concentrate. I'll give you a statement that everybody have to remember. So the statement of finding HCF in this method is very important. Let me write here. HCF statement is, it is the product of, lowest powers of only common factors. It is a product of lowest powers of only common factors. So this is very important statement and you have to remember. So let's try to prime factorize each and every number, then apply this method. 450 I'm finding prime factorization. So I know it's divisible by 2 because the last digit is 0. 2 2s are 4. 2 2s are 4. 2 5s are 10. Now it's divisible, not divisible by 2, but it is divisible by 3. 3 7s are 21. 3 5s are 15. Again it is divisible by 3. 3 into 25, 75. 5 into 5, 25. So you can stop. 990, let's prime factorize. 2 4s are 8. 2 9s are 18. 2 5s are 10. 2 2s are 4. 2 4s are 8. It's not divisible by 2, sorry. So check the next number, that is 3. Yes, 3 it is divisible. 3 1s are 3. 3 6 are 18. 3 5s are 15. Now it's again divisible by 3. 3 5s are 15. 3 5s are 15. Next it's divisible by 5. 5 into 11 is 55. So because we got a prime number, we can stop it. 1620 divisible by 2. 2 8s are 60. 2 1s are 2 0. Again divisible by 2. 2 4s are 8. I saw many students making a mistake here. Just write 5. 2 5s are 10. But that is wrong. Whenever you take two digits together, you must use 0 first. 0 5. Now it's divisible by 3. 3 1s are 3. 3 3s are 9. 3 5s are 15. Divisible by 3 again. 3 4s are 12. 3 5s are 15. divisible by 3 again, 3 into 15, 3 into 5. So because we got prime number, we can stop. So let's write the prime factoration using exponents. So for 450, how can we write? 2 repeated once, 3 repeated twice, 5 repeated twice. That means 5 to power 1 into 3 square into 5 square. 990. How can you write the prime factoration? 2 repeated once, 3 repeated twice, and 5 repeated once, 11 repeated once. 1620. What is the prime factoration? 2 repeated twice, 3 repeated 1, 2, 3, 4, 4 times 3 power 4, 5 repeated once. And according to the HCF statement just now I gave you, it is the product of lowest powers of only common factors. So what do you mean by factors here? Factors means these bases 2, 3, 5, 2, 3, 5, 11, 2, 3, 5. These are called factors. So which is common? Yes, 2 is common, I can see. So just take 2 here. 3 is common, I can see. So take 3 here. I can see 5 also. Take 5 also. But 11 is not common. 11 is only present in 990 but not in other numbers. So take only 2, 3, 5 because they said only common factors. Now we wrote common factors. Now what we have to select? We have to select the lowest powers of each of them. So for 2, what is the lowest power? 2 power 1 is there, 2 power 1 is there, 2 power 2 is there. So which is the lowest out of them? 2 power 1. So we write here 1 multiplied by. Now for 3 we have to select the lowest power. 3 square, 3 square, 3 power 4. The lowest power is 3 square. So just write 2 here. Then 5 we have to select the lowest power. 5 square, 5 power 1, 5 power 1. The lowest power is power 1. So just write 1. And just multiply, you'll get the answer. 2 power 1 is 2, 3 square is 9, 5 power 1 is 5. So you'll be getting answer 90. So the HCF of these numbers is 90 and this method is called prime factoration with exponents. So this method can be applied for even any number of numbers are there. At a time we get the answer. But if you apply continued division method, that can be applied only for 2 numbers at a time. This method can be applied for more than 2 numbers at a time. So I hope everybody understood, and any doubts are there, you can raise your hand and ask. Sudeshna, you have any doubts in this question? Sudeshna?
Sir,
Yes, you have any doubt in this question? In this method?
yes, sir.
Can you tell me?
Yes, sir. Sir, how? Sir, explain again.
See, you understood prime factorization, Sudeshna?
Yes, sir.
So for every number, first we have to prime factorize. 450, what is the prime factorization we got? 2 power 1 into 3 square into 5 square, right?
Yes, sir.
And 990, what is the prime factorization we got? 2 power 1 into 3 square into 5 power 1 into 11 power 1, right?
Yes, sir.
And 1620, we got 2 square into 3 power 4 into 5 power 1. Next, we have to select the common factors. Is 2 common here?
Yes, sir.
Okay, that's why we have taken 2. If everything is common, then only we have to take. Otherwise, we should not take. Is 3 common here, Sudeshna?
Yes, sir.
So that's why we took 3 here. Next, is 5 common here, Sudeshna?
Yes, sir.
That's why we took 5 here. But do you think this 11 is common everywhere? Is 11
No, sir.
common? No, that's why don't take 11. So take only common factors. And in that, you select the lowest power. 2 power 1, 2 power 1, 2 square. Which is the lowest power? Lowest,
Sir,
smallest.
2
Power 1, very good. And 3 square, 3 square, 3 power 4, which is the lowest power?
That 3 square.
3 square. Then we wrote 3 square. And 5 square, 5 power 1, 5 power 1, which is the lowest one?
5 power 1.
Very good. Now let us simplify. 2 power 1 means 2. 3 square. What do you mean by 3 square? 3 into 3. 3 multiplied 2 times. 3 3s are 9. 5 power 1 is 5. And just multiply all of them, you get 90. Okay?
Okay, sir.
Next, any of the students have doubt, you can raise a hand. Nishil, any doubts? Nishu, any doubts?
No, sir.
Samatrika, any doubts?
Sir,
Yes, Samatrika.
sir,
Yes.
fourth problem I didn't understand.
It's not fourth problem, it's method, fourth method. Prime
Okay, sir.
factorization without exponents. So you understood prime factorization?
Yes, sir.
First prime factorize 28. We got 2 into 2 into 7. Then prime factorize 12. You got 2 into 2 into 3. Round up
Mm,
only the common factors. Is 2 common here?
yes, sir.
That's why we rounded up. Is 2 common here?
Yes, sir.
That's why we rounded up. But 7 and 3, they are not common. Only take common factors and multiply. You get the answer. Okay?
Okay, sir. Sir, can I mute?
Yeah, you can mute. Jayant, any doubts?
Sir,
Yes, Jayant.
sir, can you zoom?
We cannot zoom because already we have filled the screen, right? We cannot zoom and which device are you using?
Sir, tab.
Tab. I hope it's visible clearly in tab.
Yes, sir.
Okay, yeah. Okay, I'll try to zoom it by taking it. Jayant, is it okay now?
Yes, sir.
Okay, copy quickly, Jayant. We have to solve some problems now.
Sir, I have copied already.
Okay, no problem. Um, Pranay, you have any doubts? Pranay, you have any doubts?
Sir, factor tree method, which numbers we have to take?
We can take any numbers, but only we have to stop the branching at prime numbers. We can continue doing factorization, but whenever prime number comes, we have to stop there.
Sir, sir, there is a composite number, but that is not, sir.
Every composite number is divisible, Pranay. Okay?
Okay, sir.
Harshvardhan, any doubts?
Sir,
Yes, Harshvardhan.
sir, the HCF of prime numbers is product, na?
It is not product. You should remember the statement. The product of lowest powers of only common factors.
Sir, I am
So if you
asking
take,
because the
yes,
2, 3 HCF means we want to multiply 2 into.
first you take common factors. In that
Sir,
common factors, you have
sir,
to take
prime numbers,
only the lowest.
but they are prime numbers, 2 and 3. How they have 1 and 2 itself.
Suppose you are taking only prime numbers.
Yes, sir.
If you take any two prime numbers, the HCF will be 1. So about those properties, we are going to discuss after discussing LCM.
In LCM, we'll tell the we want to find LCM means prime numbers product.
Yes, we are going to discuss all of them under properties. First, we will discuss the methods of finding HCF and LCM. Then, whatever you are saying, the co-primes LCM is product and HCF is 1. Everything we are going to discuss under the properties. Okay?
Okay, sir. After LCM,
Yeah, after LCM.
sir, Sunday you will finish this chapter. Sunday, not tomorrow or day after tomorrow.
Yeah, I am trying to complete. So, whatever thing is completed in this week, you'll be having a test on Sunday. Don't forget.
Sunday.
Yes. So,
Okay,
all
sir.
of you, yeah, Harshavardhan, is it clear now?
Yes, sir.
Okay, you can mute yourself. So you understood all the 5 different methods for finding HCF. So whichever question you take, whichever method will be giving easy answer, you can select that question and apply. So all of you try the next question. This question came in 2020 Sainik School exam. What will be the HCF of 216, 288, 720? Everybody try this question now. I'm giving you time. Everybody, be ready with the solution. Whatever method you want to use, you can use, but use always the best method possible. Rishikesh, what happened?
Sir,
Yes, Rishikesh.
sir, I got HF is 72.
Okay, you got the answer already.
Yes, sir.
Okay, let the other students try, then I'll come back. Varshita, you got the answer? Varshita,
Sir,
you got the answer, Varshita?
sir,
You got the answer?
yes, sir.
Which method you applied?
Sir, common division method.
Okay, let us apply common division method. 216, 288, and 720. So, Varshita, first with which number you divided all of them?
Sir, 2.
Okay, 2. 2 ones are 2, 2 eights are 16, 144, 360. Next number with which number you divided?
Sir, 2.
2 fives are 10, 4s are 8, 2 sevens are 14, 2 and 180. Next with which number you divided?
Sir, 3.
2 is still
Sir, 2.
2 is still dividing all
Sir, 2.
to complete 2. 2 into 27. Yeah, order you can say no problem, but I want to write in ascending order. 2 into 36, 2 into 90. Now 2 will work here?
Sir, no.
No, we can use 3. 3
3.
9s, 12 and 10. Again we can use 3.
Yes, sir.
3 3s are 9, 4s are 12 and 10s are 30. So any common factor is there for all the numbers now?
No, sir.
No, you have to start doing, right?
Yes, sir.
So HCF will be the product of all of them. So HCF is going to be 2 into 2 into 2 into 3 into 3. So 2 cube is 8, 3 square is 9, and 8 times are 72. Varshita, you got the same answer?
Yes, sir.
So answer D. Okay, this is by common division method we understood. Common division method. Now any student can explain the same question in any other method, not common division method. Any other method you can explain, you can raise the hand. I'll give the choice to you. Can any student get the same answer in any other method? Shanai, can you explain the same question in any other method?
Division. Sir, continue division method.
Very good. Continued division method. What is the drawback of continued division method?
Sir.
What is the drawback? What is the disadvantage of continued division method? That is, at a time we can find for 3 numbers or 2 numbers only.
Sir, 2 numbers, sir.
Okay. First, which 2 numbers you want to select between 216, 288, and 720? So
Sir, 260.
Shanai is applying continued
Sir,
division method. Wait a minute. Wait a minute. Shanai is applying continued division method. So out of these 3 numbers, first which 2 numbers you want to select?
216, 288.
Okay, you want to take first 2 numbers only. So with which number we have to divide which number?
216 divided by 288.
No, no. 288 divided by 216. That means 288 we are dividing by 216. Okay. What is the quotient, Shanai? Shanai, what is the quotient?
Sir, 1.
216 into 1, you got 216. And if you subtract, what is the answer? Subtract.
72, sir.
With 72, you again divide which number?
216.
Very good. What is the quotient going to be?
Sir, 72. 3s
Yes,
are 216.
very good. And we got the HCF. What is the HCF by this process?
72.
72. Very good. Now, how to find the HCF of all the three numbers?
Sir, 72 divided by
Yes, with 72, you have to again divide 720. 72 into 10, we got the direct answer, right?
yes, sir.
So what is the final HCF?
72.
72. We got the same answer from the previous method also.
Yes, sir.
Now, can any student explain in any other method than common division method and continued division method? Who will explain?
Sir, can I mute?
Yeah, you can mute yourself. Ritvik, can you explain in any other method? Ritvik, Ritvik, you're not audible. Ritvik, are you there? Rishikesh, can you explain in any other method than these two?
Sir?
Can you explain in any other method than these two?
Yes, sir.
Which method?
Sir, without exponents.
You want to take without exponents. Okay. That is prime factorization.
Without exponents.
Yes, prime factorization. Without exponents you want to take.
Yes, sir.
Okay. You already ready with your prime factorization, Rishikesh?
No, sir. I will tell now.
Okay, tell me.
Sir, 2 ones are
2 ones.
2 eights are.
It's not 2 eights. 2 eights are. We have to write 08 or directly?
Sir, 08.
Why we have to write 08?
Sir, we are taking two numbers, sir.
Very good. Then again divisible by?
2.
So 2 5s are 10, 4s are 8. Next divisible by? Rishikesh again. Divisible
Yes,
or
sir.
not next?
Sir, again we
What is the quotient if
have to take 2.
what is the quotient if I divide by 2?
Sir, 2 twos are.
Yes.
Sir, 2 sevens are.
Okay. Next it is divisible by?
Sir, 3.
3 9s are 27. Next.
Sir, 3.
3 3s. And finally we got prime number. Can we stop this?
Yes, sir.
And 288. You tell me the quotient also.
Okay, sir.
Just tell me.
Sir, 2.
Yes.
Sir, 144.
Okay. Next.
Sir, 2 sevens are.
Yes.
Sir, 2 twos are.
Okay. Next.
Sir, 2 threes are.
2 3s are.
Yes, sir. 2 six are.
Next.
Sir, 2 18s are.
Next.
Sir, 2 nines are.
Next.
Sir, 3 threes are.
Okay. So we got prime number. We can stop. And the next number is
Yes,
7. How can you factorize this?
Sir, 2 threes are.
Yes.
Sir, 2 six are.
Yes.
Yes, 0.
Okay. Next.
Sir, 2 18s are.
Yes.
Sir, 0.
Next.
2. Sir, 2 90s are.
Next.
Sir, 2 45s are.
Next.
Sir, 3 15s are.
Next.
Sir, 3 5s are.
Is 5 prime number?
Yes, sir.
So we have to stop. Now we have to write
Yes,
the prime factorization. 260.
yes, sir.
I'll write for you. 2 into 2 into 3 into 3
3,
into 3. And 288. We can write 2
2
into
into
2,
2
2
into
into 2,
3.
and then 3 into 3. And then 720 we can write 2
2
into
into 2 into 2 into 3 into 3 into 5.
Okay, in this method, what are we going to use? We are going to
Sir,
yes, we are
common
going
factor.
to common factors, right?
Yes, sir.
2, 2, 2. Next.
Sir, 2, 2, 2 again.
2, 2, 2. Next.
Sir, again 2, 2, 2.
2, 2, 2. Next.
Sir, 3, 3, 3.
Now there is no 3, 2 left common. 3, 3, 3. Next.
Sir, 3, 3, 3.
That's it, or anything left?
Sir, that's it.
So what is the HCF? Multiply only the common factors. 2 into 2
2
into 2.
into 3 into.
What is the answer?
Sir, 4, 4, 8, 14, 8, 8, 3 is the 24. Sir, 72.
Yes, we got the same answer again.
Yes, sir.
Very good, Rishikesh. Can any student explain in any other method? Can raise a hand now. We discussed.
Sir, can
Wait a minute, Rishikesh. We discussed common division method. We discussed continued division method, and we discussed prime factorization without exponents. All of them gave the same answer, 72. Now, can any other student explain in other method? Rishikesh, you can mute yourself.
Okay, sir.
Vaishnavi, can you explain in any other method than this? Discuss prime factorization without exponents. All of them give the same answer, 72. Now, can any other student explain in other method? Rishikesh, you can mute yourself.
Sir.
Okay, sir.
Yes, Vaishnavi.
Sir.
Vaishnavi, can you explain in any other method than this?
Sir, prime factorization with exponents.
All of them give the same answer, 70. Vaishnavi, I am able to. Did you log in
Any
through
other
two
student
devices?
explain in other method?
Vaishnavi, did you log in through two devices?
Sir,
Come again.
your voice is
Can you
repeating.
explain in any other
Okay,
method than
Vaishnavi,
Sir, only one.
Vaishnavi, I'll check your problem later today in the institute. Just be mute. There is a lot of echo. I'll check it today evening. Who will explain like Arush? Can you explain in any other method? Arush,
Sir,
Arush, you want to explain in other method?
yes, sir.
What is
Prime factorization with exponents.
yes, one more method. Prime factorization with exponents.
Sir, it is not visible.
Not visible?
Yes, sir. What you are writing, I can't see.
I think you moved your screen to left or right.
No, sir.
Is my screen visible or completely blank?
It is not completely blank, but I can see only exponents.
That means I think something you did with the your screen. You zoomed it or something. Zoom out if you
No, sir.
have already zoomed in.
No, sir.
You did?
I didn't.
Okay, no problem. I'll be writing here. Is it visible now?
Yes, sir.
Okay, now in this method, prime factorization with exponents. Already prime factorization is there with us from the previous method only.
Yes, sir.
Only let us write with exponents now. Okay. So what are we going
Yes,
to
sir.
get is first 216. Can you say in exponents form?
Sir?
Can you say in exponents form now?
Yes,
216.
sir. Yes, sir.
2 repeated how many times?
3 times.
That means 2 cube. Then
2 cube. And 3 cube.
very good. And 288. What is the exponent form we can write?
2 in the power of 5.
2 to the power of 5
And
into
3 square.
3 square. What is 720 factorization form?
2 in the power of 4.
2 to the power of 4. Say properly.
2 to the power of 4 and
Yes.
and 3 to the power 3 square
Yes.
and 5 in the power of 4.
5
5
to
in
the
the power
power.
of 1.
Okay. So now, can you recall the statement, Arush? What is the statement I told you for HCF?
The product of lowest powers of only common factor.
Very good. Only common factors. What are the common factors here we have to select?
2.
Yes.
2 in the 2 cube.
No, first let us write 2 and 3. In this, what is the lowest power of 2? Lowest power of 2?
Cube.
2 cube. What is the lowest power of 3 in this?
Square.
So, what is 2 cube, Arush?
2 cube. 8.
8. What is 3 square?
9.
9. So, it's 8 nines are 72. So, you understood all the 4 methods, Arush?
Yes, sir.
Very good. You can mute yourself. As you can see, students, any method you apply, you get the same answer. So the same question, finding HCF of 3 numbers, we did in common division method, we did in continued division method, and we did in prime factorization without exponents, with exponents. Every method gave us the same answer. This is the beauty of mathematics. So I hope everybody copied, and shall we move to the next question? Okay, I'm waiting on the screen so that everybody copy this. Any doubts can raise a hand. Rishikesh, why did you raise a hand? Rishikesh,
Sir,
why did you raise a hand?
sir, it is glitched.
No problem. Nishika, why did you raise a hand? Nishika, why did you raise a hand? Aryan, you have any doubts?
Sir,
Aryan, you have any doubts?
sir, why did you leave a blank there at the bottom right left?
Because Arush said for him it's not visible at that part. So
Okay.
he's already interacting with me, no? That's why I wrote on the right side. Lakshita, any doubts? Lakshita, any doubts?
Sir, it is 7:41. You told that I will say intelligence.
Today we will continue complete maths only. Tomorrow we'll take intelligence.
Okay, sir.
Samatrika, any doubts? Samatrika, any doubts?
Yes, sir. You
Come
now
again?
7:40 times when you start the intelligence.
Just now I told Lakshita, right? Today we'll continue with maths only. Tomorrow we'll take.
Okay.
And Jayant? Jayant, any doubts?
Sir,
Yes.
so we have to copy all methods.
Yeah, every method you need to copy.
Okay, sir.
So I hope everybody understood this, and let's move to the next topic, that is Harshvardhan. Any doubt?
Sir,
Yes.
sir, today we are giving result status exam.
That is not a point of discussion in today's class.
Okay, sir. Sir,
Next, so we're moving into the next concept, that is LCM. So LCM also we have some methods. First of all, we go for definition method. So method number 1, we are going to discuss definition method for LCM. I think there is a question following this. Let's take the same question. Okay. So definition says LCM means lowest or least, lowest common multiple, lowest common multiple. For example, we want to find the LCM of 4 and 6. So it's based on multiples. A number has infinitely many multiples. First, let us write the multiples of 4. 4 ones are 4, 4 twos are 8, 4 threes are 12, 16, 20, 24, 28, 32, and so on. We can write so many. And 6, there are some multiples, infinitely many. 6, 12, 18, 24, 30, 36, 42, and so on. Now we will list out the common multiples. What are the common multiples? So we have 12 is a common multiple, 24 is a common multiple, and after 32 we are going to have 36 and so on. So we can write one more also, 36. Like that, common multiples also infinitely many we are going to get. Let's list out 12, 24, and 36. And according to the definition, we have to say LCM means lowest common multiple. In all the multiples, common multiples, which is the lowest one, that is 12. So therefore, we can say the LCM of 4 and 6 is 12. So this is the definition method for finding LCM. Next, let us check the second method, that is method number 2. Method number 2 is common division method. But this common division method from HCF is quite different. In HCF, we will divide only if all are divisible. But in LCM, we will divide if at least 2 are divisible. Even if all are not divisible, no problem. At least 2 are divisible, we will take. So this method also can be used for more than 2 numbers at a time. For example, let's take 20, 44, and let's take something like 60. So for these numbers, we are going to find LCM in common division method. So let's take 20, 44, and 60. So if all are divisible, okay, no problem, we can do it. But even if all are not divisible, at least 2 are divisible also we have to take. So first 2 will work. 2 tens are 20, 2 into 22, 2 into 30. Again, all are divisible by 2. 2 fives are 10, 2 11s, and 2 15. Now, clearly there is no factor 2 now. Next, by checking 3 also, at least 2 should be there. So 3 also not dividing, but 5 is dividing both of them, 5 and 15. But 5 is not dividing 11, then also there is no problem. We can still continue. For HCF, we cannot take 5, but we are finding LCM, no? At least 2 also divisible we can take. So I am taking 5. 5 ones are 5. So 11 is not divisible by 5. Whenever it is not divisible, you take the same number as it is down. So 11 is not divisible 5, write 11 only. 5 threes are 15. And there are no common factors left, you can stop doing the process. Then LCM we can find, that is 2 into 2 into 5 into 11 into 3. No need to consider this 1, because anything into 1 will be 1. 2 and 5 keep it separately. Why? Because it's going to create 10 and we can add 0 easily at the end. 11 threes are 33. 33 into 2 is 66. And for this 2 into 5, use a 0 here. So 660 will be the answer. This is common division method. And next we have method number 3. Method number 3 is prime factorization with exponents. So for HCF we discussed 5 methods, but for LCM we have only 3 methods. So prime factorization with exponents we are going to discuss. So let's factorize 20 first. 2 tens, 2 fives. And factorize 44. Same question I'm taking. 2 into 22, 2 into 11. 11 is a prime number, will stop. 60. 2 into 30, 2 into 15, and 3 into 5. 5 is a prime number, will stop. And we will write the factorization. The factorization is 20 is nothing but 2 into 2 into 5. Let's write with exponents. 2 square into 5 power 1, and 44 we can write 2 square into 11 to the power 1, and then we can write 60. 60 is 2 square 3 power 1 and 5 power 1. So I'm writing a statement for LCM. You have to remember HCF. It is quite similar to HCF statement, but two things will be opposite. So for HCF, I'm recalling this statement. It is a product of lowest powers of only common factors. But for LCM, it is a product of highest powers of all the factors. For HCF, lowest powers of common factors, but for LCM it is quite different. In place of lowest we got highest, in place of common we got all the factors. So this is LCM statement. So let me use this statement in identifying the answer LCM. Now they said all the factors, whether it is common or not, you take everything. 2 is there, you write 2. 3 is there, you write 3. Even though it is not common, no problem, you write 3. 5 is there, you write 5. Everything involved, you write 11 is there, you write 11. I wrote all the factors. Now for every factor, they said highest power. 2, what is the highest power? 2 square, 2 square, 2 square. Everywhere is same, you can write square only. 3, the highest power. There is only one power, you write 1. 5 power 1, 5 power 1. Highest power is also 1. And 11 is 1. So we're going to multiply. So 2 square is 4. 4 into 5, 20. 20 into 33, we'll get the same answer, 660. So any method you apply, you're going to get the same answer. So these are the three methods we discussed to find LCM: definition method, common division method, and now we discussed prime factorization with exponents. We have only three methods for LCM, so you can copy. I'll be waiting on the screen. And any doubts, you can raise a hand. After that, we'll move to the problems. Panaswini or Jyoti, who is that?
Sir, I didn't understood the method 3.
Method 3 you didn't understand. See, Manaswini, you understood the prime factorization first?
Yes, sir.
Prime factorization of 20, what we got? What is the prime factorization of 20 we got?
What, sir?
Prime factorization of 20, what we got?
Sir, 2 power 2 into 5 power 1.
And 44, what we got?
2 power 2 into 11 power 1.
60.
2 power 2 into 3 power 1 into 5 power 1.
And what is the statement for LCM?
The product of highest powers of all the factors.
So every factor I wrote. Because 2 is there, I wrote 2. 3 is there, I wrote 3. 5 is there, I wrote 5. And 11 is there, I wrote 11. HCF we found common factors, but LCM will be finding only all the factors, not only common factors, all the factors. Now, you check only 2, Manaswini. In the first number 20, what is the power of 2?
2 power 2.
And this one?
2 power 2.
And this one?
2 power 2.
If I ask what is the highest one, again 2 only, no?
Yes, sir.
That's why I wrote 2 square here. Okay? Okay, Manaswini?
Okay, sir.
There is only one power for 3. And that will only be the highest, right?
Yes, sir.
And similarly, 5 power 1, 5 power 1, both are same. So that will only be highest.
Yes, sir.
And similarly, 11 also there is only one power. That will only be highest.
Yes, sir.
So answer will be 660. Okay?
Okay, sir.
Any other doubts?
No, sir.
Okay, let's see some question. All of you try to solve this question now. So this question came in 2023, 2 years back. If a number is divisible by 8 and 3 both, then by which other numbers will it be always divisible? Who want to say the answer for this can raise a hand. Daksh, can you explain? Daksh?
Sir, I think option C is correct.
So why?
Yes,
Can
sir.
you explain?
Sir,
Can you explain why?
so because the product of 8 and 3 is equals to 24, sir.
It's not the product, it's the LCM. Okay?
Yes, sir.
So there is a number. There is a number. What is the number? We don't know. Let us call x. It's divisible by 8. We get the remainder 0. Same number, if you divide by 3 also, you get the remainder 0. So in order to get that type of number, we can find a LCM. So the LCM of 8 and 3, because 8 and 3 are co-primes, what is their LCM?
Sir, 24.
Product. 8 threes are 24. So co-primes LCM is product that we are going to discuss in the next section, tomorrow's class, properties. Now, every factor of 24, what are the factors of 24? We'll write all of them. 1, 2, 3, 4, 6, next 8, 12, 24. So, they are divisible by, if a number is divisible by 8 and 3 both, then it is divisible by every factor of 24. 1, 3, 4, 6, 8, 12, 24. So, answer will be C, factors of 24. Correct answer, Daksh.
Yes.
You can mute yourself. Next, one simple question they were asking. The least common multiple of 3, 4, 9. Shall I wait on the screen so that everybody copy? So last question for today's class. You can see at the bottom of the screen, the least common multiple of 3, 4 and 9. So we discussed 3 different methods. Any method you can apply and find the LCM of 3, 4 and 9. Sudesh, now you are getting an error, no internet connectivity. Okay, I'll check in today's class. Lakshita, you have doubt. Yes, Lakshita, tell me what is your doubt?
Sir,
Yes.
sir,
Yes, Lakshita.
sir, I have not understand definition of method.
Definition method is very simple, Lakshita. See, we want to find the LCM of 4 and 6, right?
Yes, sir.
What are the multiples of 4 we can write? 4 ones are 4, 4 twos are 8, 4 threes are 12, etc., right?
Yes, sir.
And what are the multiples of 6? 6 ones are 6, 6 twos are 12, 6 threes are 18, right?
Yes, sir.
And round up the common multiples. 12, 12 common.
Yes, sir.
24, 24 common.
Yes, sir.
36, 36 common.
Yes, sir.
That's why you wrote all the common multiples here. Okay?
Yes, sir.
And LCM means what? Least common multiple or lowest common multiple. In these common multiples, which is the lowest one?
So 12.
That's why 12 is the LCM. Is it clear?
Yes, sir. I have cleared.
Okay. Now, anyone got the answer for this question? Can raise a hand. Find the LCM of 3, 4 and 9. Harshvardhan, can you give the answer?
Yes, sir.
Yes, tell me.
36.
So, which method you applied?
Sir, I applied a prime factorization method.
The better method to solve this question is common division method.
Common division method.
Yes, let us apply common division method. So, which number you took to divide?
3.
3 because both are divisible by 3. Even though 4 is not divisible, no problem because this is not HCF. 3 ones are 3, 4 is not divisible, you write 4. 3 threes are 9. Any common factors left?
No.
Can we stop this?
Yes.
So what will be the LCM? 3 into 4 into 3. What is the answer?
36. 12 threes are 36.
Yeah, answer is A, that is 36.
Sir, in LCM we want to multiply this prime numbers 4 and 3 also.
No need. No need. Why? Because there are no common factors. No, we can stop.
When the common factors are not there, we want to multiply that also in last.
Yes. If common factors are there, we can continue.
This is only right side.
Yes.
Okay, sir. Sir,
Okay. Yes. Okay, you can mute yourself. Okay, student, that's it from today's class. Okay, all of you participated really well today and gave answers. So leave today's class feedback in the chat box and you can leave the class. All of you can leave the class after giving feedback. Yes, Vikram, you can leave. All of you give the feedback of today's class and you can leave the class now.